Hello everyone, welcome to my channel. I am Srivastava. I hope you are doing extremely well and are fine and shine. So today we are going to solve the rotten oranges problem in continuation to the Samsung playlist. So let's move to the question now. The question says you are given an m cross n grid where each cell can have one of the three values: 0 representing an empty cell, 1 representing a fresh orange, and 2 representing a rotten orange. Every minute a fresh orange is, that is, four directionally adjacent to a rotten oranges becomes rotten. Okay, one more time. Every minute any fresh orange that is four directionally adjacent to a rotten oranges become rotten. Now return the minimum number of minutes that must elapse until no cell has a fresh orange. If that is impossible, return -1. Okay, so we have read the question. Now let's go to the examples now. So the question says we have been given an array where there are three types of entries: 0, 1 and 2. 0 represents empty, sorry, 0 represents empty cell, 1 represents fresh oranges, 2 represents rotten oranges, right? So now if there are any rotten oranges, any fresh orange which is present in the four directions will be converted to rotten oranges in 1 minute. This is what the question says. Any rotten oranges will make the adjacently placed fresh oranges into rotten oranges in just 1 minute, right? So this is what the question says. Now let's move to the example 1. We have been given a rotten oranges at 0, 0. So as the question says, in the four directions it can make the fresh oranges into rotten oranges. So these will be converted to rotten oranges in time t equals to 1, right? So now they are rotten oranges now. So again, for this 2, this one will be converted to rotten oranges, this one will be converted to rotten oranges, right, at t equals to 2, next 1 minute. Now this 2 again will make this 1 as 2 rotten, so t equals to 3, and at t equals to 4 this 2 will make this fresh orange into rotten oranges. So the answer is 4, right? Now let's move to the example 2. So here again we have been given a rotten oranges. Now this 2 rotten orange will make this 1 rotten in t equals to 1 minute. Now this rotten oranges will make this one and this one, this one and this one rotten in next 1 minute. So at t equals to 2 we have 2 more rotten oranges. At t equals to 3 this rotten oranges will make this 2 rotten one. At t equals to 4 this 2 will make this rotten, and this will be left, right? As you can see, this will be left because now this 2 and this 2 both can't make this as rotten because it is of, like, we are considering only 4 directions for conversion, right? So the 1 will remain fresh only, so the output is -1 because we have to return -1 if any of the fresh oranges left fresh. So now let's move to the example 3. The example 3 has no fresh oranges, as you can see, so the answer is 0, right? So this is the boundary condition. So now we have understood the problem. Now let's move to the algorithm. Which algorithm we are going to use? So the algorithm we are going to use, which algorithm we are going to use to get the minimum amount of time elapsed when all the fresh oranges converted to rotten one. So the first of hint is minimum. Whenever you are asked to give the minimum number of time, the only thing comes in my mind is BFS. The second hint is, let's consider a example. 2 1 1 0 1 2 0 1 1. This is our example 4. So here we have been given 2 rotten oranges at a single time, right? So now if we just change the color. So now what should be the time elapsed for all fresh oranges being converted to rotten one? So for this 2, at t equals to 1, at t equals to 1, this 2 will convert this one into rotten. This rotten orange will also make this one rotten, this one rotten, and this one also rotten in just t equal to 1 second only, right? And in t equals to 2 second, this one also be converted to rotten one. So the answer will be t equals to 2 second. So with this example, what we understood that this 2 converted with this rotten, this 2 and this 2 also converted, which means all the fresh oranges which are present at one distance from the rotten oranges will be converted to rotten. Or if I say all the fresh oranges which are at level 1 from the rotten oranges are converted to rotten one. So let me reiterate this. What I was saying is, if so I was saying all the ones, this one and this one and this one, all these three ones are at distance 1 from the rotten oranges. So all three will be converted to rotten in just t equals to 1 second only. And in next 1 second, this one also be converted because of these two rotten oranges. So the answer is t equals to 2, minimum time to cover all the fresh oranges into rotten one. So my point is, we are traversing similar to the level wise fashion, right? And whenever we are traversing level wise, what comes in our mind? the BFS. So now I think we understood why we are using BFS. Okay, let's one more time, let's try to check DFS, how many time it will take to cover the same grid in DFS approach. Let's suppose we are using DFS. So how DFS works? Depth first search. So it will try to go in depth. So it will call the DFS on this. Then this will go here. Then this will go here, and then this will go here. So 1, 2, 3, and 4. So the answer will be 4 minute, because every time we go into depth, we are increasing the time by 1 minute, right? So with the DFS approach, we are getting 4 minutes, which is definitely not the minimum. The minimum time we already saw is t equals to 2 minutes. So the algorithm is clear now that we are going to use BFS. So let's code it now with the BFS approach as we discussed. So we have been given a 2D grid. So let's find out the rows and column. Now in BFS approach, we need a queue and a visited matrix. So we'll make quickly queue of vector type, because we need to store both row, column, and the time instance. So we are using the vector. You can use pair also. For the Boolean visited matrix, I prefer vector only. You can use I use array only. You can use vector also. So now it's time to initialize both queue and the visited Boolean matrix. So let's initialize. So if the grid position is 2, that means rotten oranges, we need to push its position in the queue. Also, the time instance, currently the time is 0. We need to mark it as true. Reason, because it is already visited. We have pushed it in the queue, so it is visited now. Else if grid is equals to 1, that means fresh orange, we need to mark it as false, because we need to cover it and make it as rotten. Else means what? Like grid of ij equals to 0 means nothing present. Visited of ij equals to true, because we are not going to cover it. Already it has nothing, neither rotten oranges nor fresh oranges. We will just mark it as visited. So we have initialized our queue and Boolean matrix. So let's start with the BFS. If queue is not empty, we need to pop it. We will take out the first element, remove it from the queue. Now we need to check all the adjacent four directions whether is any fresh oranges present. Temp of 0 is having x coordinate of the rotten orange plus dx of k. The dx and dy are direction variables that I have discussed in my previous video. You can go and check out if you don't have any idea. And the time is temp of 2 plus 1. This is the thing, because now we are moving to the next level, from the current level to the next level, the adjacent four directions. So we need to increase the time because it takes 1 minute to cover the adjacents. Okay, we can make the variables in the outside the loop so that it will not create every time. x1 y1. Also we will need a time variable to store the final time elapsed to rotten all the oranges. If is valid, if is valid x1 comma y1 comma n comma n, we need to check the validity of the index. Also grid of x1 comma y1 should not have 0, or basically we can directly check instead of x1 comma y1 equals to false, right? Then what we need to do, we need to add it in the queue. x1 comma y1 comma t1 mark it as visited because it is already added in the queue, and we can update the time as t1. This is something we will need in last. So we have completed the traversal. After the traversal we need to check it if any fresh orange is still left or not. Then check if visited of I comma j equals to false. If any grid or any cell is still having visited as false, that means fresh oranges left because we have marked them as false. We need to return as -1 as the question says. And if we have completed the testing and haven't returned -1, so we can return the time because we have updated it, right? So I think this is the final solution, and let's test it. Before that, let me complete the direction variable that we have created in dx of 4 that we have used, sorry. Alright, so we have completed the direction variable, we have taken out the grid, we have used the Q and a boolean visited matrix, we have initialized it. If grid of I is 2, we have added in the push, we have added it into the queue, we have make it as visited. If it is having fresh oranges, we have just made it false, and if it is having 0, that means nothing, we have marked it as true. We have applied BFS approach, then we have tested it that any fresh oranges shouldn't left, and if it has not left any fresh oranges, we have written the time. So let's test it now. Okay, so we forgot to add the is valid function also. Okay, so we forgot to add the is valid function also. Bool is valid if I greater than equals to 0 and I less than m, and then j greater than equals to 0 and then j less than n, we can return true, else we can return false. Right, so now just test it. So we just forgot to initialize the time variable, that is why it was not working. So now let's run this. So it is accepted locally. Now let's run for the full test cases. So guys, as you can see, it is submitted, and let's meet in the next video from now.